Welcome everybody. Today I'm going to start solving some past paper questions in paper 1 about the topic of moles. So before we start, just pause the video and read this question carefully. As we can see, this question describes the chemical reactions between metal carbonate that are in acid block, which means they could be in group 1 or group 2 with excess hydrochloric acid. Since you're describing a chemical reaction, you should write a balanced chemical equation. In this case, you should write it. So the metal carbonate, as we can see, let's start doing it. MCO3 plus excess HCl. You know that once you make reactions between acid and metal carbonate, you will have carbon dioxide gas, water, and MCl. We don't know if whether the metal here is in group number 1, as in potassium and sodium, or in group number 2 as magnesium and calcium. Let's complete the question. This amount of 0.833 grams of carbonate releases this amount of gas measured under room conditions. What's meaning of gas in under room conditions? From the mole ratio, you should put in your mind at each 1 mole of gas under room conditions, they will produce a volume of gas of 24 cubic decimeter. And as you can see here, it's given to you in cubic centimeter. And that's why you should change the cubic centimeter into decimeter by dividing over 1,000. All right. My target here is to calculate the number of moles of gas, which is carbon dioxide. So you will take the 200s and divide them over 1,000 in order to have them in cubic decimeter. And you will have this number decimeter, and this is X in here. At this moment, you can calculate the number of moles of CO2, and they are equal to 0.008333 moles. All right. Now, put in your mind, our target is to identify the metal carbonate in order to identify it. And since we have the moles of carbon dioxide and we have the mass of carbonates, then we can calculate the MR. But the problem here is, how can I confirm that the moles of carbon dioxide, which are 0.00833, are same as the metal carbonate? And this is very simple. For example, if you want to balance the number of carbon atoms in here, like CO2, if you have 5 carbon dioxide, then you definitely should have 5 moles of metal carbonate in order to have the same number of carbon. And that's why we can assume that the number of moles of carbon dioxide are same as the moles of metal carbonates. All right. We can say that the moles are equal to mass over MR. And since our target is the MR, then we can divide the mass, which is 0.833 over 0.00833, and then the MR is 100. And now if you go to the periodic table with doing some calculations on the MRs, we can conclude that the metal carbonate that has MR of 100 is CaCO3. And if you do it it's 40.1 plus 12 plus 16 times 3, and then it will equal 200. And that's why your answer is D.